Alright, the last section in this unit is probably the most difficult, but it is also the most used. And if you search factoring trinomials, there are so many different strategies. I'm going to show you the AC method because it actually works for two different types of trinomials, and you only have to memorize one process. So that's my choice. If you don't like this method, you're welcome to search on YouTube and see lots of other ways to do it. So we've done perfect squares with 2 terms. Common factoring can be all terms. Grouping has 4 terms, and a trinomial will now have 3 parts to it: x squared, a bx term, and a number at the end. So that's called a trinomial. So there can be a coefficient in front of the x squared. It can be 1 or another number, but this method works for both, so you don't have to do anything differently. So for the AC method, what you're going to do is, first, I'll just write it, but terms in order, and I will give them to you, but in case they weren't, you just want to put them in order. But the first step is you're going to take AC and you're going to multiply them together. So we're going to do A times C. And then this is where it gets a little tricky, but you want to come up with 2 factors that add to get B. Okay? And then once we do that, we're going to replace, that's a B with the 2 factors, and then we do factor by grouping. Now, this sounds long. Once you do a couple, you'll understand it. And like I said, this is probably the most used type of factoring in the next class, Secondary 3, and some of the future sections in this course. So if you learn this now, it really will make that a lot easier. So I tried to say that now. Do it correctly now. It is tricky. It is not super easy for some students, and I will be happy though if you want to email me and you want to do it one-on-one, let me know. Okay, so let's get into it. So on the first one, I'm going to leave my steps up there so you can kind of see it. The terms are in order. So on the side, there's like a 1 here. I've got A and C. So I've got 1n squared times 9 gives me 9n squared. Okay. Now I need to come up with what times what that will add to give me -10. Well, if I have 9 times 1, that'll give me +10. So if we want them to be a -10, -9 plus -1 is -10. And we also need to split up the n squared. So -9n plus -1n does add to give you -10n. So that's what I mean, factors that add to give B. Okay? So my next step is I'm going to replace this with these 2 terms. And it doesn't matter the order. So I'm going to write n squared, and then I'm going to put minus n minus 1n. And then I copy down the C. So notice I don't change the original equation, I just rewrite it, but it's still equivalent. Then we end up having 4 terms. So you just got done doing factor by grouping, and we're going to do it again. So we can take out an n. These don't have anything in common, so I can take out a -1. So if we divide by -1, we're left with n minus 9. Our factors are the same, so we know we did it correctly. All right, let's look at our next example. And feel free, if you get the idea, 1, 2, and 3 are all typically the same, and then it does get a little different, but not really on the last examples. I have more than what you probably need, just to make sure that I have enough. So watch as much as you need. So we've got b squared times 8, so I'm going to write it on the side. And then I need the factors that will give me a -6. So you think 8 times 1, I can get 9 or 7. 4 times 2. So 4 times 2 will give me 6, and if I need them to be negative, and we're going to split the b's up. So let's try red. We get b squared, and then like I said, the order will not matter if you put the 2 or the 4 first. I won't prove it to you, but just trust me. We're going to do common factoring. So in the first two terms, we can take out a b or divide by a b. In the next two terms, we want to divide by a -2. So divide by -2, divide by -2, and they do match. So you get b minus 2, b minus 4. Let's do the next one. I made a higher power, but it's the same idea. So we're going to multiply these together. And I wanted to see how these both have an 8 and an 8, but the middle number is different. So I wanted to do another one that looks very similar. So to get 9, I can do 8 times 1, and then you're still going to split up that x to the 6, and you always want to make them the same. And so that's where that x cubed come from. To get a -9, I do want these both to be negative. So x to the 6th. So even though it is a trinomial, it can be a higher power. It will work out, or there was a typo. Okay. So in the first two terms, we can take out x cubed. So if I take 3 of those x's out, take all 3 of those out, and nothing in common, so we're going to take out a -1, and our signs match. So x cubed minus 1, x cubed minus 8. And for our class, this is done factoring. Later on in another class, you'll learn that this can keep going, but that's not until secondary math 3. All right, so now when we add this number in front, for our class, since we know the AC method, this is not going to be any different. On YouTube, if you watch videos, this will be different compared to how they do those problems. So we're still going to do a times c, so we get 12n squared. The factors of 12 that will give us 8. And it'll take you a while to get those factors. I do get it on my first try, but I've been doing this forever. -6 and -2, and then we split the ends up. So 3n squared minus 6n plus 4. We're going to group. We can divide by a 3 and take out an n. So n minus 2. And here we can divide by a -2. So 3 outsides go together and the insides go together. Okay? Like I said, I'm not going to do anything different in the next 4 problems, so if you have the idea, you're welcome to keep going. Multiply these together. I need the factors of 15 that give me 8. Oops, I said 8 and then I wrote it. 3 times 5. And I need to split that up, x squared. To get a -8, I need both of these to be negative. So x to the 4th. All right. Look at the first two terms. We can take out an x squared. The next two terms, I can take out a -5. So x squared minus 3, x squared minus 5. Now, we might be able to go further because this could be the difference of perfect squares, except 3 and 5 don't break down. But if this was a 9 and a 4, then we could factor a different type. And that will come in the next section. All right, the next one is going to be just a bigger number. So we get 210 u to the 4th. So this might take even me a little bit because 210 is pretty big. So I always see a 0 here and I think, what about 10 times 21? Well, that'll give me 31. So then what if we divide by, I want to think, so 3 times 7. So you can try these factors. And I think I actually have a typo here. Because I could have 30 and 7. So I'm going to change this now, and then I'll change my notes worksheet. We're going to make this a 3. I think I made an error. Okay, so we're going to go back to this, because there really is no way to get 41. It's just mathematically not possible. So that's my error. So u squared. And to get a positive, I want both of these to be positives. All right, I'm going to change colors because I got messy. So we're going to get, I'll do it right here. So 7u to the 4th plus 10 plus 21 plus 30. The numbers 7 and 10 don't have anything in common, but I can take out a u squared. So 7 and a 10. 21 and 30, they both can be divided by 3. So 7 and 10, and they do match. So u squared plus 3 and 7u squared plus 10. Now, once again, this could be the sum of perfect squares, except that 3, we don't break that up. All right, the next two, just more practice if you want to see them. We've got 3 times 14, which is 12, 1, 42. And 42, the factors, I always think of 7 times 6. So let's see, oh, and I just want to get a negative 1. So 7 times 6. If I want to get negative 1, I can do 6 minus 7. Okay? And we're going to split up the u's. So u squared, u squared. So we get 3u to the 4th minus 7u squared plus 6u squared minus 14. So see, I don't have to put the 6 with the 3 and the 7 with the 14. It won't matter. Well, we can take out a u squared. So 3u squared minus 7. 6 and 14, I can divide by 2. And it works out. So u squared plus 2 and 3u squared minus 7. All right, the last one, if you're still here with me, we can multiply, we get negative 100. Oh, I meant to write that as a negative. Oops. Okay, you might have got that. Negative 100 in squared, and I want to get 15. So I think 10 times 10, but that'll give me 20. So what if I do 20 times 5? So if I want to get negative 15, I get negative 20 and positive 5. All right, so 4 in, oops, I'm going to draw a line here. 4n squared minus 20n plus 5n minus 25. Well, we could take out a 4n, divide, and divide by 5, positive 5, and they match up. All right, I have done a lot of examples, but please email me if you want me to do some with you. I can totally help you and make this a little less complicated. All right.